5.3, rates of change and slope. What do we know about slope? Jackson's going like this. Can we also go like this? Could go like this.
Go like that.
Go like that. Right, so we've got multiple ways to talk about slope. Sometimes slope and rate of change is kind of the same thing. In this case, we're talking about the rate of change. So rates, your heart rate, beats per minute, your speed, miles per hour, those are all rates. You guys should have learned about that prior to now. So if we have a rate of change, then we need to compare two things. Well, your rate of change is the change in the dependent variable over the change in the independent variable. Now let's think about dependent and independent. I feel like we just had this on our test in chapter 4. Which variable, x or y, is the dependent variable? The y, right? And the independent is the x. So we're doing the change in y over the change in x. Okay? So rate of change problems usually occur with word problems. So let's go ahead and look at one. Just put the table down, don't put all the words. So what we have here in this table is we have an average temperature for 5 months in a certain city. We want to find the rate of change for each time period. And then we want to pick which period the temperature increases the fastest. So we've got month 2, month 3, month 5, 7, and 8. And then we've got the corresponding temperatures. So in month 2 is 56 degrees Fahrenheit. In month 3 it was 56 degrees Fahrenheit. In month 5 it was 63 degrees Fahrenheit. 7 it was 71. 8 was 72. So to decide our rate of change, we're going to do exactly what we did when we were looking for linear functions. I want to see the change in the x, and I want to see the change in the y. So from month 2 to month 3, what's that change in x? It's a plus 1, right? From 3 to 5, it's
2.
Plus 2. From 5 to 7, it's
2.
Plus 2. 7 to 8 is plus 1. Now, right now, I'm not worried about it being linear right now. I'm just thinking about change, because that wouldn't be linear, right? Because it's not consistent. All right, now let's go to the bottom. 56 to 56 plus 0. 56 to 63. Yeah. Sorry, I was writing 4. 63 to 71. 71 to 72 plus 1. All right. So we want to find the rate of change for each time period. So from month 2 to month 3, how much is it changing?
0.
The temperature is changing 0. Because what is rate of change? Rate of change is your y over your x. So let's make a list over here. So from 2 to 3, our change is 0 over 1, which is 0. Month 3 to 5, what's your change?
7.
Over 2. So in average, because aren't we jumping 2 months?
Yeah.
Here we're only jumping 1 month, so we need to make it consistent. So on average, the change is, what's 7 over 2 reduced to?
3.5.
That's 3.5, right? 3.5? So 3.5 on average for each of those months. Now let's go from 5 to 7. What's that one going to be? 8 over 2, because we're jumping between 2 months. So on average, it would be 4. And then 7 to 8, it's going to be what? 1 over 1, which is 1. So for which period did the temperature increase at the fastest rate? 5 through 7. Does everybody see that? Because that's your largest. So the fastest rate is month 5 to 7. Okay, so your fastest rate of change is 5 through 7. Yep. So the reason why we have to think about what's in the bottom is if I would just say 8, well then I'm not comparing like things. Right now I'm comparing a change of 1 month here and a change of 1 month here. Here I'm comparing a change of 2 months. So to be able to compare the change of 2 months with 1 month, you need to reduce it and think about, well, what would it be if I took it to a unit rate? You guys remember that word? Unit rate?
No.
You should. You did it at some point in time with Mrs. Leonard. So you take it down to a unit rate so you're comparing all things. Aiden.
So basically it's just the denominator in the chart over the numerator in the chart?
Yep, your y over your x.
Yeah.
So you take your change of your y, put it over your change in your x. Okay? All right, moving on. We're not going to graph it. So, your slope of a line. We're talking about the rise over your run, right? So when we're talking about the slope of a line, we know that the rise is going to be the difference in the y values of 2 points on a line. And the run is the difference in the x values of 2 points on a line. Difference means we're doing what operation? Subtraction, right? Okay. So rate of change usually deals with some type of word problems when you're talking about rate of change. If we're talking about a line, specifically a linear equation, which is the same thing as a line, we're talking about the slope, and your slope is rise over run. Change in y, change in x. It means the same exact thing, it's just a different lingo. When we're dealing with word problems, we talk about change of rate. When we're talking about an actual line on a graph, we're talking about slope. They both represent the same thing. You might have in your science class, have you seen this before? Delta y over delta x? Yeah, same thing. Change in y over change in x. Okay, so use delta to mean change. All right, so if I give you a line, hopefully we can figure out what the slope of it is.
Yeah.
Hopefully.
Yeah.
Is everybody good?
Yeah.
Sure?
Yeah.
Going once, going twice. Sold and gone. All right, so what I want you to do is make a quick rough coordinate plane on your notes and plot the point 0, -3, and 5, -5. So 0, -3, and 5, -5. Put a line through it with arrows on both ends. All right, how can we find the slope of that line? Using the idea of rise over run. So what I like to do, so I like geometry, so I like to make right triangles. I like to turn my line into a right triangle because one of the legs of that right triangle represents the rise and one of the legs of that right triangle represents the run. Now we gotta figure out which is which. So let's think about this for a second.
1, 2, 2, 5.
Rise is the difference in the change in which values? The y. So if you think about your rise, you're going either up or down, right? So this line right here represents my rise. Is it going up or is it going down?
Down.
It's going down and then it's going
Down.
over. So my rise is how many units? 2. But since it's going down, it's going to be a -2. Now my run, so if you think about you running, you're either running forward or you're running backwards. It's a little bit harder. In this case, we're running forward. How many units? 1, 2, 3, 4, 5 units. I'm running in the +5 direction. So slope is your change in y over your change in x. So what's the change in my y? -2 over 5. Does anybody know what variable we use to represent slope? N. We'll get to that tomorrow. N is,
Y equals mx plus.
yeah, we will get there. No, not tomorrow, but we'll get there eventually. So a lowercase m you can use to represent slope. So we'll say our slope is -2 over 5. Now what if I would have made my right triangle go like this instead? What if I would go up this way and over that way? Let's think about it that way. Now my rise ends up being +2 and my run ends up being -5. Do I still get -2/5?
No.
Sure. 2 over -5 is the same as -2/5, right? So it'll get you there no matter what. Okay, so given a line, can you figure out the rise and the run?
Yeah.
Hopefully. All right. So horizontal and vertical lines. Let's talk about those slopes. So before I even get there, you guys can write this down. I'm going to tell you a little story about my first time skiing.
Yay.
First time skiing. I was pretty little. So let's say my first time skiing, I was really excited. I was probably like 5 years old, and I was pumped up to go on my first skiing trip. So I got on the chairlift, and I went up the chairlift, and I had a really positive outlook in my mind. And I'm like, yes, I'm doing really, 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 really good. Okay? Then I got to the top, and I bottomed out. I was thinking, okay, I'm doing all right. I'm having kind of no change of thought. And then I went down the hill, and what happened to me at the bottom?
Crash.
Crashed. Hit another kid, I fell over, I sprawled out. So my trip down had a very negative experience, right? Okay. So we got our positive, we got our negative. And then I went a little bit, and then what happened to me right here? I fell down a what? Cliff. Broke my arm. I didn't do that part. This part happened. Okay, so positive, negative. Think about going up, coming down, having a negative. So if I have a vertical line, think about me falling down that cliff. Didn't really fall down a cliff, but pretend. Would there be any slope there? No, there isn't. Because now think about this. Slope is your change in your y. So first of all, I can't even make a right triangle here. But how much is my y changing from this point to this point? It's going down 1, 2, 3, 4, 5, 6, right?
Yeah.
Is it running anywhere?
No.
No. Can you divide 6 by 0?
No.
What happens when you type into your calculator 6 divided by 0?
Error.
Don't do it. The world's going to explode if we all do it at the same time. So what does that mean?
That's an error.
Well, it means something. It's not no solution.
It's just six.
It's something.
6.
Undefined. Okay?
Yeah.
Is that pretty much no solution?
It's not no solution. No solution means that there is no solution. Undefined is a solution.
Just not found.
Right, it's just not a number. It's undefined, but it's something. So it is a solution, but it's not an actual number. So if you have so somewhere in your notes you might want to write, a vertical line has undefined slope. What about a horizontal line?
Same thing.
Zero. It'll be zero.
Is it rising?
It'll be zero
No.
over.
No. Is it running? 1, 2, 3, 4, 5, 6. What does 0 divided by 6 make?
Zero.
0. So a horizontal slope should have a slope of
Zero.
0. Okay, so let's turn this into a really fancy, organized fashion.
Oh.
All right. Positive slope looks like what?
Goes up.
Going up that chairlift. Negative slope looks like what?
Going down.
Going down, crashing at the bottom. Going down. Undefined slope looks like what?
Vertical.
Vertical line. Good.
Horizontal.
0 slope
Horizontal.
is going to be a horizontal line.
So.
Okay, so you should be able to identify all the different parts. Nick, what's the matter? All right, let me make sure I got all my bases covered here. That's it. Questions? So you should be able to identify whether something is positive, negative, or undefined. All right, I'm going to give you some time. I'm going to do a different worksheet. We'll say that for another day. Save our holiday problems for next week.
I have a question. So like on snow days, like say we had homework that was due that day, would you post like the homework that we have to do for like say it was a Monday? Over the weekend we do the homework that's due on the weekend, so that like Monday would we have more homework that night?
No.
Yeah.
Just wondering.
Most teachers don't do that. All right, so if you look at your homework, you're doing both sides. You've got a good 11 minutes, or 10 minutes, not 11, 10 minutes. You can start working on it. So the front side is your rate of change problems. Dealing with the word problems. You're finding your rates of change for each time period, and then you got multiple choice down at the bottom. On the back is where you're looking at the slopes of physical lines and determining the rise and the run. So so it's changing by 1 for all your x's, right? And what's the y's are they changing by? So 2.98 minus 1.49 is 1.49. 4.47 minus 2.98. Is it all 1.49? So your rates of change is for every weight, for every pound, it's changing by $1.49. Would be a good way to describe it. Did everybody get that? For number 1 on the front. So for every pound, the cost changes by $1.49, or increases by $1.49. So make sure when you're describing it, you talk about both variables. Should I say it again, Aiden?
Yes.
For every pound, so every increase of pound, you're increasing the cost by $1.49. Well, it changed, so over 1. 1 over 2 is plus 1, plus 1, plus 1.
Yeah.
This is plus 1, makes 4, 9, plus 1, makes 4, 9.
So 1 plus 1
Right, we over 2. Yep. Or the change from 1 to 2, which is 1.
Oh, so all of them are over 1.
Yes.
So then, It's the same every time.
Yeah, it is in this case.
Nah.
Oh, yeah, probably. That means for every pound, we're going up by $1.49.
Is that the rate of change? Will it be like, will it be consistent for everyone?
I throw it up here on the board, give me 2 seconds.
All right, so for problem number 2, for those who are stuck,
Yeah.
those who aren't, just keep going. The answer is, let me look here. I'll just scroll down and find it.
21.5. How do you know?
So from 9 to 11, it's 0.75, 11 to 12, it's 2, 12, 13, 3.5, 13 to 15, 2.
I'm at your sister.
And then you had to rank them. Is that what you're doing?
Wait, you have 7.7.
All right, 9 to 11, we're going up by 2. 11 to 12, 1. 12 to 13, 2. Good. What's this going to be? Is it 1.5? 2.
3.5.
And 4. All right, so from 9 to 11, it's going to be 1.5 over 2. What does that simplify to? What's half of a 1.5?
7.2.
Yeah, 0.75, 3/4, right? Then if we go from 11 to 12, it's 2 over 1, which is just 2. We go from 12 to 13, that's 3.5 over 1, so 3.5. 13 to 15 is 4 over 2, so that's 2. So find the rate of change during each time interval.
That be your answer?
For this part. When did the greatest rate of change occur? Twelve to 13, right? It's 3.5.
That's the rate of change?
No, these are all your rate of changes because they're different.
Oh.
So this would be your answer for that.
So that's all we're doing?
For that part, yeah. And then when did the greatest rate of change occur? 12 to 13. When was the rate of change the least? 9 to 11 was only 0.75. Just so happened that the first table they gave you, the rate of changes were the same each time, so I didn't have to break it down by each change of pounds. Let's go ahead and do number 3 together. Can I get rid of this one?
Oh, you can get rid of the screen, I just need that.
Wait, during which 2 time periods? Were they the same? 11, 12, 12 to 13.
Alright, so number 3 says show the distance of courier from her destination. Alright, so we're just looking from 2:15 to 2:30. Okay. 15. If you want to do 15 minutes, if you want to do minutes, that would be fine. 15 minutes, and then the distance here is 0. Well, that's easy. So what's the rate of change? 0 miles in how many minutes? 15 minutes. What does this rate of change mean? Well, that's what it means. So I guess we should have said the rate of change is 0. It means we go 0 miles in 15 minutes. No, because you're doing y over x, so it'd be 0 over 15. Good question. Oh. Alrighty,
And he said,
and hopefully you can figure out the multiple choice ones.
11, 12, and 13. Wouldn't it be 11, 12, and 13?
For-
No, it says one of the same. They each got 2 for 11.
Oh, I missed the question where they're the same. 11 and 12, 13 and 15, both were 2. Didn't have that one scrolled down all the way. Alrighty, whenever you feel like you're a good stopping point, I'm going to start cleaning things up. Please make sure you put your chair up. Work on the rest of this over the weekend.
Are we in this class till 1:20?
Oh, we are.
Come it.
We are in here till 1:20. I was thinking it was like the end of the day and it was 2:15 by the time we got here. You got 6 minutes. Keep working.
The rise is down, right? I'm supposed to go down.
It's hard because you guys are my last teaching class of the day, so I always feel like it's the end of the day.
Yeah.
You guys are
I
here.
wish it was the end of the day.
Right.
But,
Well, I was ready to head out the door.
Isn't that the answer before?